today we're going to be talking about similarity in the context of right triangles. So today is all going to be about special ways that you can solve using proportions inside of right triangles specifically. So something pretty cool that happens in right triangles, which is illustrated in this top part right here. Have you guys ever heard of an altitude before in the context of a triangle? I'm sure you've heard of the actual word altitude before. But in a triangle, the altitude represents the height of a triangle. So to get the height, you have your triangle sitting however it is. You would draw a line from the vertex down to the side across from it, so that's perpendicular. So this right here is the altitude. We use the altitude more in unit 10-ish to talk about like volume and surface area and stuff like that. So make sure you keep that word in the back of your mind for the height of a triangle. But in this context, when you guys draw an altitude inside of a triangle so that it hits the hypotenuse, you guys remember that word, right? I know you remember that one. Hypotenuse, that's the side across from the right angle. If you want to label that too, in case you don't remember what a hypotenuse is. So if you draw the altitude so that it crosses the hypotenuse, it actually breaks your triangle into 3 different options, right? This one is the entire picture. You guys see the full triangle, right? That's one of the triangles. Then you have the left-hand side, which is gray here, and then the right-hand side, which is that brick kind of shaded in. So I have 1, 2, 3 triangles total. All 3 of these are similar. All 3 of them. Right? This is true for every right triangle. If you were to draw the altitude inside of a right triangle so that it hits the hypotenuse, all 3 of these triangles that you create, the full picture and then the 2 parts, they will always be similar, right? So this is really helpful because if we know that they're all similar, we can use that idea to help us solve really easily within these diagrams. So we're going to talk about those 2 ways of doing that in a second. First, I'm going to talk about more specifically how we can tell what sides correspond when you actually separate the triangles. So we're going to switch to this example right here. I'm going to redraw the triangles and use the letters to name the ends, right? Or sorry, the corners. And then we're going to determine what the corresponding sides are, right? So I'm going to draw the full picture. I'm just going to redraw this triangle as the full picture. That's always the easiest one to draw. You just copy. Right? I did not do a very good job with that. Try again. Those of you who are more artistically inclined will have an easier job. Right? So that's the full triangle. What would the corners be? What would this corner be? C. And this one? A. And this one? Okay. So that's the full triangle. That's easy to draw. Now this line that I drew right here, that's the altitude. That splits our triangle into 2 different ones, 2 smaller ones. So I'm going to draw those now. So I'm going to draw this smaller one, which looks like, oh, try that again. This is the right angle. Right, looks like that. This corner is C, this corner is A, but what's this corner? D. Right, so everybody see that? This point right here is the corner of the smaller triangle. And then I'm going to draw the medium-sized one, which looks like this. Here's your right angle. You have A, D, and B. Right. So get used to being able to see all 3 triangles, being able to redraw them. It's easiest to redraw them if you try to keep them in the same orientation as they were in the original picture. It makes it a little bit easier to draw. Okay? So now what we're going to do is we're going to figure out what the sides that correspond are, but just by looking at the picture. Right? So I'm going to label the sides with an S for small, M for middle or medium, and L for large or long. Okay? So let's look at the big triangle. Right? This side would be the S. It's the shortest. Right? You use your visual to interpret this if they don't give you numbers. So clearly this side is the shortest one. What side has to be the longest in the right triangle? The hypotenuse. So I automatically know that this one's going to be the long side across from the right angle. So then this side right here is the medium side. We use a different color actually. Okay. Now we're going to do the exact same thing but for the other sides. So in this triangle, which one would be the smallest? You can use the letters to name it. This one? No. The shortest side would be CD. If your drawing is bad, you can always look back at the original to see. This is the shortest between these 2. What's the longest side? The hypotenuse, which is CA, which leaves DA to be the medium-sized one. And then in this triangle, the one in here in the picture, what would the shortest side be? DA, the longest, which is AB, and the medium would be DB, right? Once you label all the sides with S, M, and L, all of the S's correspond, all the M's correspond, and all the L's correspond, right? So it's just as simple as that when you're looking at the picture. Now I'm going to ask you guys specifically what sides correspond with AB. So AB in this picture is right here, right? So basically you want to do, excuse me, when they're asking about AB, they're referring to AB in the full diagram, right? So in the big picture that was M, right? What are the other sides that have M? Look at what you drew. Which one? DA and what's the other one that has an M? DB. So separate and label them, and it makes the question a lot easier, so you can see that. Right, in the big triangle, CB is right here. What letter is that? L. CB.
Oh, look at the big triangle.
Yes, we are always looking at the big triangle. You want to write that down? Alright, CB in the big triangle is the longest side. So now we're just looking for all the other L's. CA. What's the L on this one? AB. So all those sides are corresponding. Alright, and then lastly they want us to look at CA, which in the big triangle is the smallest side. So I'm going to find the smallest sides in the other two triangles. So it's the smallest one over here. Which one? CD. And what's the smaller one over here? AD or DA, doesn't matter what order you put them in. Okay? So that's how you approach these questions. If they ask you to find corresponding sides, draw the triangles separate from each other, use the visual to figure out which one's small, medium, and long for each triangle, and then match them up. Okay? So that's not as often what you'll see, but just in case they ask you to find corresponding sides, that's how you would do it with these triangles. Alright. Before we go on to those two special rules for solving, I want to introduce a new vocabulary word. It's called geometric mean. And when you guys have heard of mean before, it usually means average, right? Like add them together, divide by 2. That's what the algebraic mean is in algebra. When we're talking about the geometric mean, it's something different. Okay? So the geometric mean is the value x, where a over x equals x over b. It's a really abstract definition, but I'll talk about it in a second. So the geometric mean is the value x, where a over x equals x over b. Now remember on day 2, I think it was, when we introduced the idea of ratio and proportion, I told you guys 2 vocabulary words, the extremes and the means, and I told you that the means were coming back. That's this, right? So the means are these 2 numbers, and the extremes are these 2 numbers. So if you guys are trying to find the geometric mean, it's basically saying that these 2 numbers have to be the same. They want to know what are those 2 numbers where they would be the same. And then these 2 numbers here, a and b, are going to be provided in the question. So the kind of question they're going to ask you, if they ask you for the geometric mean, obviously they want you to solve for x, right? So we have x represents the geometric mean, and you still have to use a proportion. We are using this proportion right here to help us solve. The x is what we're looking for, which is called the geometric mean, and the a and the b are the 2 numbers that they have provided. So they give you everything you need. They give you the a and the b, and then this is the equation you will solve. Right? So just memorize this equation for the geometric mean, plug in the a and the b that they provide for you, and then cross multiply to solve. Right? I know you guys don't like memorization, but this is something you have to memorize and how to find the geometric mean. Okay? So if that is our formula, if our formula is a over x equals x over b, what would a be in this scenario? Because I gave you 2 numbers. It would be the 9. So I would have 9 over x, and then what would I plug in for b? 4. Okay? And I need you guys to cross multiply so we can actually solve for x. Not 2x. What is x times x?
X times X. Squared.
X squared. X squared equals 36. Okay? So I just multiply them together, and now I kind of want to undo that, right? If I know that x squared is 36, what does x need to be? How do I solve for x? Take the square root. If you take the square root of both of these to solve for x, what's the value of x? 6. Ta-da!
So that means the square root will be a decimal.
If I ask for a geometric mean and it's not a whole number, I want you to leave it as a square root that's simplified, just like for distance formula. Okay? Alright, so then again, in this question, they've given me a and b, and I'm trying to solve for x using this formula you have to have memorized. So I plug in a, I plug in b, and then I cross multiply. What would I get? If I cross multiply, what do I get? X squared equals 20. Now, is 20 a perfect square like 26 was? No. So when you guys take the square root, you're going to get the square root of 20. But just like when we were working with the distance formula, you need to make sure that your square roots are always simplified. Okay? So how would I simplify the square root of 20? Okay, find the biggest square root that's a factor of 20, 4. So it separates into 4 and 5. Whatever the perfect square was, you're going to take the square root of that. So what's the square root of 4? 2. So the 2's on the outside, 5's on the outside. Alright, we've worked on that before. You guys should know how to simplify square roots. Just letting you guys know that if you do run into a square root, I do expect it to be fully simplified. Okay? Just like with this formula. Alright, here's another one. We have 9 over x equals x over 8. We plug in a and b using the formula for geometric mean. Cross multiply. X squared equals what? 72. Take the square root. Is 72 a perfect square? No, it's not. So we're going to do the same thing that we did for the 20. We need to figure out how to simplify the square root of 72. So what do you guys think? 36 times what? 2. Okay. So whatever the perfect square is, you need to take the square root of that, so it's the square root of 36. Alright, so 6 comes on the outside, but it stays on the inside. 2. So the answer would be 6 squared root of 2. And then lastly, 3 over x equals x over 7. You cross multiply, you get x squared equals 21. You take the square root to get x by itself. Instead of being x squared, you want to make sure you solve for x. So you take the square root. Is the square root of 21 a whole number? Can you simplify it though? Can I split 21 into 2 numbers where one of them is a perfect square? What perfect square would it be? No? Okay, so there's no factors of 21 that are perfect squares. So would I be able to simplify this, or would I leave it like that? You would just leave it. So if you can't simplify, that's fine. Just leave it as the square root that it originally was. Okay? So that is part of this lesson because the geometric mean is actually relevant to the right triangles. So not only will I be asking you to do the questions we're about to talk about, I may also ask you about a geometric mean in this lesson or anything that relates to a right triangle. Alright, so make sure you have that formula memorized and you know how to use it in order to solve for the geometric mean. Alright, next up in our last concept for today is talking about these 2 rules. There are 2. I call them method 1, method 2. I actually have other names for them, but we'll talk about that in a second. So there are 2 different scenarios that they could provide. Obviously, the picture is going to look the same. You're going to have a right triangle, a big right triangle, with an altitude drawn down the middle. Okay? We have that scenario happening for both of these. But the difference between these pictures is that you're either going to have the altitude labeled and the sides not labeled, or you're going to have the sides labeled and the altitude not labeled. They give you one or the other. They won't give you both. Okay? So there's a different method for each scenario. Right? This one, I didn't have a name for it, but in years past, my students have called it Splash Mountain. I honestly don't know why, but they thought that was a good name for it, and I'll explain why. So the splash mountain rule, if you want to refer to that, what you do, this is what I would draw for my kids to help them understand how this worked. When you guys are writing the proportion, because again, they're similar triangles, so we're using proportions to solve. That's our foundation for this unit. As you guys are writing the proportion, you guys are creating a little mountain like this. And it doesn't matter what direction you go in. You could also go this way if you wanted to, right? Which I think is what happened here. So you would start with the hypotenuse, so B, this section right here. Then you would go to A, right? And then you would go from A to C. So you draw these little arrows, and that helps you understand how to write the proportion. You go from B to A, and then you go from A to C when you're writing the proportion. So there are two ways you guys can do this. You can either memorize how to do it with the arrows, or you can just memorize the formula.
So basically, whatever the hypotenuse is going to be the x.
No, the positions, like for the geometric mean that we were just talking about, that's actually the altitude. The A.
Oh.
See how A is the altitude here? So whatever the altitude is, that would be where the x's were in the previous equation, and then the two pieces of the hypotenuse would go here. The B and the C? No, it doesn't. Because again, remember we were talking about equivalent proportions, so you can switch the extremes and it doesn't change it. Okay? So here's an example. I'm going to show you exactly how to use this process here. So here's an example, and the directions would say solve for x. When you notice that it's a right triangle, and it has the altitude labeled, you guys can either memorize the formula and plug it in, or you can draw these little arrows and go that way. So the first number I would write down would be 5, and then under that would be 2. Oops. And then to start the next proportion, I would have, you have the edge of the arrow to the point, and then the edge of the arrow to the point. So you have two different arrows. You can go the other way if you want to. I'm just going in the same direction as the formula here. Okay? So then it'd be 2 over x. So if you like visually, a lot of my students were more visually inclined than memorizing formulas. So they would draw the arrows, and then whenever the arrow is, see how I'm connecting the 5 to the 2? That's the first ratio. And then I connect the 2 to the x. That's the second ratio. So they just drew the arrows and then copied down what they were connecting, and that helped them create the proportion themselves. So feel free to do that, or you can just memorize how the formula works and go that way too. Once you write the proportion, you just cross multiply like we had before. So 5 times x equals 4. This one's decimal. What would it be? 4 divided by 5?
0.8.
0.8. Right, so that's how this one works. This is when the altitude is labeled. You would use the kind of the splash mountain rule, as my students like to call it. Right, that's when the altitude is labeled. However, in this scenario, the altitude is not labeled. Instead, they've given you the 2 legs of the triangle. Okay, there are actually 2 different ways you guys can approach it. You can either use the left leg, or you can use the right leg. Whichever leg you guys choose, whichever one they give you, the way that you write the proportion is different. Now, this one I've actually called the roller coaster rule. And you'll see why when I draw it. This one's even harder to memorize because of the plus, the adding the 2 pieces together, and the fact that there are 2 different ones. So a lot of my students really didn't like having to memorize that. So, let's say that you guys were going to use side A. You didn't know side D, they gave you side A instead. The roller coaster rule, and I'm going to draw it and then explain it, okay? The roller coaster rule looks like this. Okay? So what you're going to do with the roller coaster rule, when you have a roller coaster, have you guys ever been on the launch ones before?
Yeah.
Okay. You know, you have to, what? Those are the best.
No, I mean,
You have to start pretty far back, right? In order for a roller coaster to have enough momentum to go through a loop, you have to start pretty far back, right? So for this rule, in order to start this loop that I've drawn, you have to start at the very, very corner across from the side. Right? You don't want to start, can you just start in front of a loop and be able to get around? You need to get speed in order to do that. So you're going to start as far away from the side as possible. You're going to go towards the side, loop around the side, and then end right here, right next to it. Okay?
you have to just go.
No, I want you to loop around it because I'm going to show you why. this number that I just circled repeats itself in the formula. See over here, when I was using side A, do you see how it repeats itself? So that's how the roller coaster rule works. You go from C to B, first part, and then A. And then you loop around A, and then you end at B. That's the roller coaster rule, alright? The path that you take on the roller coaster is how you write the proportion. You cross C plus B first, then you go around A. Then you still going around A for your loop, and then you end at B to finish. Yeah, for the other way, and it's going to be a little bit confusing if I draw both, but if you're using side D, you start over here, B plus C over D, D over C. Okay? So if you guys are given one of the sides, you can use the roller coaster rule or memorize the formula here to help you solve that. Okay? So in this example, notice how the altitude is not labeled, I have the side instead. So I like to highlight this. You either highlight the altitude or you highlight the leg to show which scenario you have. So I have the leg here. I'm going to start as far away from that as possible so I have momentum to get into my loop. Right? So I'm going to start over here at this corner. I'm going to go momentum, loop, and end. You're going to draw your roller coaster, and then I'm going to actually write the proportion. So what's the first part of my track? Y plus 2. And then I went around 8. And then before I could finish, you have to have 8 again, and then over 2. That's how you write the proportion. And then you solve, cross multiply. Alright, so we have 2y plus 4 equals 64. 2y equals 60. Y equals 30. Alright, so the little rules here with the little names and stuff, obviously amusement park theme, that's to help you write the proportion, but actually solving it is just cross multiply. Okay, so we're going to practice that. Turn the page, we have a bunch of examples. What I want you guys to do in the notes is to write down M1 or M2, so you remind yourself which method we're using, which one would match the picture best, and then we're going to use those rules to help us solve. So, for this one, again, to tell the difference between method 1 and method 2, you decide whether the altitude is labeled or one of the legs is labeled.
Are they ever going to be both labeled?
Yes, but if you're trying to find two different variables, so you'd use one method for either of them. We'll get to that a little bit further, okay? So in this scenario, I only have one variable I'm solving for. What's labeled, the altitude or the side, or leg? The altitude. So am I going to be using method 1 or method 2? Method 1, which is our splash mountain, okay? So you can draw your arrows, and the arrows represent how you're going to write the proportion, right? So this arrow represents 12 over x, right? And this arrow represents what?
X over 27.
X over screech to a halt. Do I know what this is? It's 27 minus 12. Okay? Don't rush too fast. You guys know what this bracket means? You guys understand what that is? So this bracket's saying that the whole thing is 27, but you need to break it up into pieces for either of these two rules. So if I know this is 12 and the whole thing's 27, what would this be? 15. So you may need to pause for a second and do that before you proceed with the question. So this would actually be x over 15. Right? So please make sure you're looking out for that you have the two little pieces individually if they give you the whole thing as well. Alright, so how would I solve this once I've written down? You would cross multiply. So you would get x squared equals 180. And then what would you do from there? Okay, square root of 180, we're going to need to simplify that. Biggest perfect square that goes into 180.
Excuse me? What's that next to the one that
I'm splitting what we're simplifying 180 right now. Sorry? Nope, you can have bigger. So it'd be 9 times 20, and there are still more perfect squares inside of 20. So I'm going to keep going to find the biggest one. There's one bigger than 9.
12. 12.
12 is not a perfect square.
90?
90 is also not a perfect square.
36.
36 times 5. Alright, 36 is the biggest perfect square. So you want to take the square root of 36, which is 6, and then the 5 stays inside. Your answer would be 6 squared root of 5. Okay? Alright, this question. Is it method 1 or method 2? This is method 1 because the altitude is labeled. So this is another method 1 splash mountain. Alright, I draw my little arrows. What would my proportion look like? X over 10, 10 over 25. They had the pieces broken up for you already. Okay? So, say again. 100 equals 25x. So this one doesn't involve squaring. You don't always get squares when you do these problems. So then how would you solve for x? Divide by 25, x is equal to 4. Everybody okay with the first two? Nope. Alright. What is labeled in this picture? The altitude or the leg? The leg, which is right here. They didn't do the altitude, they did the leg instead. So is this method 1 or method 2? This is method 2. This is your roller coaster. Okay? So for your roller coaster, you need to start as far away from the leg as possible so you get momentum. So what point is furthest away? This one right here. Okay? So this is where we're going to start. We're going to go along the hypotenuse, loop around the leg, and then end right here. Make sure what you're going around is the leg that I just highlighted. So you'll go across the full hypotenuse, loop around that, and then end at x. What? What's wrong with my picture?
Oh wait, I'm looking at the wrong question.
Yeah, we're on the second row. On the second row. Alright, so we drew the loop. Now how would the proportion actually look when I write this down? And I know you guys are going to make a mistake, but go ahead.
So,
What would I write?
27. 27 minus, no, yeah.
Just 27?
27
Just 27.
Okay. Oh wow. Okay.
minus x.
Oh,
Just
minus?
27.
It's just 27
Over 18.
over 18 equals,
18.
yes. Okay, good. Well, I wasn't expecting that. Normally people will say 27 plus x. Right? It's not 27 plus x, again, because of the bracket. Right? The bracket's already telling you what the full length is. The 27 already includes the x. So everybody clear on this? Because this is the most common mistake in this lesson. Is when you guys see the bracket and another piece, you're tempted to add them together. But this has already been accounted for in the 27. So if you guys see a bracket, you don't have to add. It's 27 over 18 equals 18 over x. So when you multiply, 27x equals, I don't know what that is. 4. What do you get when you divide?
Cool.
Alright, so just really quickly one more time before I move on. If you guys see a bracket, it gives you the full length. That is the number you would use. You do not have to do 27 plus x. The x has already been taken into account within the 27. So please do not do that. Alright, which method? This, the leg is highlighted. How do you tell what? The altitude is this one in the middle.
Oh yeah, I know that.
Okay.
I was gonna ask how do you know the leg, but then I was like, oh wait, it's not mine.
Yes, either of the two sides is not a hypotenuse. Alright, so this is method 2, which means it's our roller coaster. So you want to go as far away from that leg I just highlighted as possible, which is here. We're going to go across the hypotenuse to gather momentum, go around the leg, and end right next to it. Okay? So, using the roller coaster rule, what would my proportion be? Can we simplify that? 4x plus x is 5x over 10 equals 10 over x. So again, when you have it cut up into pieces, make sure you add them together, but because they're like terms, just instead of writing 4x plus x, just go ahead and combine like terms. So it's 5x over 10 equals 10 over x. How would I solve this?
Isn't it 4x?
Nope, 4x plus x.
Would it add 5x times x?
Yes, 5x squared equals 100. Now, please remember your algebra. What do I do next? Divide. I have kids in algebra 2 who still try to take the square root before they divide. Don't do that, right? Get x squared by itself before you do the square root. So when you divide 100 by 5, what do you get?
20.
Now you can take the square root. Now that the variable's by itself, you can take the square root. You need to simplify that. I actually did that already. Square root of 20. Simplified. 2 square root 5. Right, because it splits into 4 and 5. Square root of 4 is 2. Right, so again, whenever you guys have a coefficient, make sure you divide that away first and then take the square root. Alright? Guys want to see if you can figure this one out on your own? You tried and you stuck already? Okay. Okay, this is a tricky one actually. I remember this one. There are 2 legs labeled. That's what's interesting about this one. Both of them are labeled, but you're only supposed to use one of them. You gotta figure out which one to use. Yes. Why would I want to use 7 as opposed to the 10? The fact that it's a hypotenuse in another triangle is not really going to rule it out. It's something else that rules it out. Watch. If I were to use the 10, wouldn't my roller coaster look like this?
You wouldn't get a variable.
Yeah, I don't have anything here, right? When I do the roller coaster roll using 10, I don't have a number. There's nothing there, right? So can I use that side? That side's not helpful, but if I do the roller coaster going this way, do I have all the pieces I need? I have this, this, and this. Okay? So you don't want to use leg that's labeled 10, right? Because it doesn't have enough information to actually do the proportion. But for this one, it does. It does have all the information you need. So again, this is the leg we're going to use. This is method 2, roller coaster. So you go as far away as possible. You go across the hypotenuse, loop around the leg, and then end at the piece next to it. So what would my proportion look like? X over 7. Yes, very good. And again, this is another situation. Do not say x plus 6. This bracket is already saying that the whole length is 6, so you do not need to add them. Okay, that's what the bracket represents, the full length. All right, cross multiply. 49 divided by 6.
8.1.
Let's round. 8.2. That's right. Here's a decimal. Go ahead and just round to 1 decimal point. Okay. I'm going to pause on these 2. I want you guys to try your own individually for this one because there's only 1 variable. So go ahead and take a second to see if you can figure out this one. We're solving for C. And then we'll talk about these 2 because they have 2 variables in there. You have to work a little bit more carefully. They gave me a leg, right? They didn't give the altitude. They gave me a leg. So you have to go across from the leg, loop over the hypotenuse, circle around the leg, and then end at the piece closest to it. So your proportion should be 25 over 18 equals 18 over C. When you solve that, you get 12.96. Okay?
If I were to see how they saw this.
Can you turn your paper? You can.
Did you get it wrong if you rounded it on the test?
I would not be happy if you did that. Because if you show me your work and the proportions right, then you give me 13, I mean, I wouldn't.
Alright, so like what about like on the decimal?
On the decimal, they would not round it. They would have the options as the decimals. That's why I want you to get used to just doing it like that.
Well, what if, like, so those questions will not be like one of those type in answer questions where you like
Type in? Oh, for typing questions, they would not make it vague like this. They would give you an answer that's a whole number or a specific fraction, or decimal, so you wouldn't have to worry about the whole rounding stuff. Or they would tell you in the directions whether it's round or not. Alright, so now we're going to switch over to these 2. These are 2 diagrams that have 2 variables, so we're going to have 2 different questions to solve. They've just merged the 2 pictures together, alright? So it's your choice which variable you guys want to start with, but sometimes the way that the picture's set up dictates which one you have to do first. So if we go back up to this question, can I solve for y first?
No.
In order to solve for y, that's the method 1, right? I would have to go from here to here, and then from here to here. But do I know x?
No.
You don't want to mix variables, right? You don't want to have y and x in the same equation. That's not helpful. So I can't solve for y first. I'm going to have to solve for x first. Okay? So x is right here. That's part of the hypotenuse. I'm going to be using method 2. Right? If we're solving for x, we're going to pretend this isn't even here. So if we erase that from the picture, what method would I use? Method 2, the roller coaster. Okay? So if I ignore y for a second, and I'm trying to solve for x, I'm going to be using 12 to help me do that. So the roller coaster rule looks like this. To help us solve for x. Kind of just ignoring y for a second. So what would my proportion look like to solve for x?
X plus 8 over 12.
Okay.
To 12 over 8.
Good. The full hypotenuse, which is x plus 8, that's the full path here, over 12 equals 12 over 8. Right? Then we cross multiply. So we have 8x plus 64 equals 144. 80.
Yeah.
X equals 10. Everybody agree? The algebra? Okay. So now that we know x, can we put that in the picture to help us solve for y now? Okay. So now that we know x, we can put a 10 here, which gives us the information we need for y. So I can draw my little arrows. Your triangle doesn't need to be upright to use a mountain rule. Splash mountain, you can still do it. Alright, so now you're going to go from here to here, and then from here to here. So what would my proportion look like?
Wait, what was I saying?
We're looking for y now, so I just found x, and now I can find y.
So, no, I did mine 8 to 1.
Okay, that's fine. You can, that's fine. You can go either direction. Either direction is fine. You'll get the same answer. So if you were to go the other direction, like Oscar is, 8 over y equals what?
Equals 1.
Yes. And again, you could go the other direction. It would just make these two switch, and it doesn't matter because you're going to be multiplying them anyway. Okay? So then you get y squared equals 80. Y equals square root of 80. Then you simplify that. 16 in. Good. So x would have been 10, and then y would have been 4 square root of 5. Alright, everybody picking up what I'm putting down? Alright, go ahead and try that last one on your own. Again, it is another mixed picture, so you have 2 different variables to find. Figure out which one you need to do first, and then away you go. You guys should hopefully get 15 for x and 12 for y. Yes?
Yeah, I have solved for 1 here.
Go ahead and try and see if you get 12.
Oh, yeah.
Like exactly 12?
Exactly 12.
This is like the right angle. So this means that this side is the hypotenuse, and then it has the side that's farthest away from the hypotenuse, which is this. Is the hypotenuse. So the first way would be this. Now go over the
Nope,
hypotenuse.
16.
And then
Alright, this one does require that you guys find this side to be 16, or else you can't solve for y. That's what the proportion should look like for y.
Wait, how's that 16?
Because it's 25 minus 9. You need to know this.
But wouldn't that whole thing already be?
The whole thing is 25. In order to do Splash Mountain, so you can find y, you have to do 9 over y and then y over this piece, which is 16. Alright?
x equals 15. And then
Is everybody clear on that?